Well, we're going to review redox. To start, let's remember, redox is talking about electrons changing places. The only type of chemical reactions that don't have electrons changing places are double replacement. Okay? Otherwise, the electrons are going to change place anytime an element becomes part of a compound, or an element in a compound becomes an element on its own, or an element that's in a compound changes his oxidation number as the reaction occurs. Okay? Oxidation reduction. Oxidation is loss of electrons, and then one way to remember that is LEO. Loss of electrons equals oxidation. The other one is oil. Oxidation is losing. Okay? Gaining of electrons, gaining electrons is reduction, or oil, the complement for that is rig. Reduction is gaining. Okay? What does that mean, gaining electrons? Well, that means you're adding more electrons. Okay? We all know protons are positive. We know in a neutral atom, protons are equal to electrons. Okay? If you have an ion, and the ion is positively charged, the protons are going to be greater than the electrons. There's more protons than electrons. So if you're losing electrons, you're becoming more positive. So your charge is going to go up, so to speak. It's going to, if you think of it as a number line going up and down, your charge, if the negatives are down here, -3, -2, -1, 0, 1, 2, 3, you're going to go, your charge is going to increase. If the ion is a negative, that means the protons are less than the electrons, the number of protons. There's more electrons, so you end up with a negative charge. All right. There's a review on oxidation. Losing electrons, if it loses a hydrogen, gains an oxygen. Reduction, if it gains electrons, gains a hydrogen, loses oxygen. Okay? So, here is what's going on in this case. Copper here. Copper has 29 protons. And he's neutral, so he has 29 electrons. All right? Over here, copper still has 29 protons, because if that changes, he's not copper anymore. But he has 2 less electrons now. Okay? So he had 29, he lost 2, so now he has 27. Okay? Same thing going on with the silver. The silver has 47 protons here and 47 electrons. Over here, I lied. He's positively charged. That plus is throwing me off. He has 47 protons and 46 electrons. Over here, they are equal. So we added an electron into the silver. He gained an electron. Now, the way to tell is we write half reactions. Okay? Copper, up here, he's got 29 protons, and he has no charge. He is becoming copper with a 2+ charge, still has 29 protons. If he has a 2+ charge, we've got to balance out that 2+ charge. 2 plus, 2 minus would equal 0 over here. That's oxidation. Reduction, you've got in the example up there, silver with a +1 charge. Silver has 47 protons. He's only going to have 46 electrons here. He is becoming silver with no charge, so he is gaining an electron. All right, so we have a positive +1. He's gaining 1 electron. That plus and minus cancel each other out. I did have one student that used to like to do it like this. instead. Okay? That is not conventional, but you can do it that way if it makes you feel better. All right? Convention is that you're going to have your electrons, if they're lost, they're being given away. They're no longer part of that copper. Okay? Think of this is equal. Okay? Here, 29 protons, we have 29 electrons, right? Here, 29 protons, we would have 27 electrons up here, plus 2 more electrons. That adds up to 29. Here, we're going to have 46 protons plus 1 electron, or 46 electrons plus 1 electron equals 47. Count your electrons. Okay? To identify what's going on, we have to know oxidation numbers. And you guys, we've been over that. You have a list of notes. Basically, if it's a metal, the metals are going to have the charge that they have on the periodic table. Okay, if it's in family 1, it's a +1. Family 2, it's a +2. If it's any of the transition metals, it could be a +2, it could be a +3. You have to use a little bit of brains to figure out which one it is. Okay, the oh gosh, I can't talk tonight. The non-metals, because they're making covalent compounds, their electrons are being shared, and we know that electronegativity is how attractive something is. So the stronger the electronegativity, those are going to tend to be negatively charged, and the weaker ones will tend to be positively charged as far as the electrons being shared. Okay? But the best way to do it, you just have to remember the basic rules and try to add everything up to 0 unless it's a polyatomic ion. For instance, got a page in here. I can't see behind my little... Did I get a page? Oh, it's because I'm hitting the wrong thing. All right. For example, here's a typical ionic compound, calcium chloride. We can look at the periodic table. Chlorine makes a -1 electron. There's 2 of them. We know calcium's +2 because he's in the second family. +2 minus 2 is 0. But what about this guy? Sulfur dichloride. Once again, chlorine is a halogen. And the rule on halogens, fluorine is always -1. Chlorine is always going to be -1 unless he's with oxygen or fluorine. So, he's with sulfur. That's not oxygen. That's not fluorine. He's a -1. There are 2 of them, total of 2. That sulfur has to be a +2. Okay? What if I give you that guy? We just said chlorine's a -1 unless he's with an oxygen. Here, we know oxygen's a -2. So this chlorine would have to be a +2. Right? Okay. So, we have to figure out in a set of equations what is being oxidized and what is being reduced. Actually, I want to pull this up. I found this one. First, let's practice oxidation numbers. Okay? Carbonic acid. Everything has to add up to 0. Oxygens are always -2. There are 3 of them for a total of -6. Hydrogen's going to be +1 when he's with nonmetals, and there are 2 of them for a total of +2. 2 plus what? -6 equals 0. +4. Carbon is +4. Here, nitrogen is sharing electrons with his friend nitrogen. They both pull equally. 0. He does not have a charge. Zinc is always a +2. He's bonded here with hydroxide. Let's draw that out. Now, there's 2 ways to do this one. Hydroxide, if you think about it, you know that that's always a -1. But let's go ahead and add it out. What's oxygen always going to be, unless it's a peroxide or with fluorine? It's a -2. There are 4 of them, right? So we have a -8 there. Plus 2 there. Hydrogen, when he's with a nonmetal, he's a plus 1. There are 4 of them. So now, we notice up here also there's a negative 2 charge overall. That means that this has to add up to negative 2. Does it? 8 minus 8 plus 4 would be minus 2 plus, can't do math. 2 plus 4 would be 6. Plus 6 minus 8 is equal to negative 2. Nitrate, again, we have an extra electron, so we say that we have to add up to negative 1 instead of 2, or instead of 0. Oxygen's always negative 2. Negative 2 times 2 is negative 4. What does nitrogen have to be? He'd have to be a plus 3. Lithium is always a plus 1 because he's a metal. That means hydrogen here has to be a negative 1. All right, this guy. He's tricky, okay? Oxygen's always a negative 2. We have a negative 8. We have 3 irons. So 3 times what will give you negative 8? Well, 8/3 would, but that doesn't make any sense. What really is happening here, oops, remember that iron has both a plus 2 and a plus 3 charge. So one of these irons is a plus 2, and the other 2 are plus 3s. I'm not going to give you anything like that. All right. Now we've practiced identifying redox or oxidation numbers. Now we're going to figure out what's being oxidized and what's being reduced. Oil rig. Oxidation, you're going to have electrons being given away, so your charge is going up. For a reduction, the electrons are going to be on the left side of the arrow. Okay? Now that's really for half reactions. We're not doing half reactions yet, but we can with these. All right, what's chromium's number? He's a plus 1. It tells us that. Tin is a plus 4 here. Here, chromium's a plus 3. What did chromium do? He went from a plus 1 to a plus 3. Did he go up or down? He went up. He went up by 2. That means, let's see, chromium's atomic number is 24. That would mean he had 23 electrons here, right? 24 minus 23 would be a plus 1. And that would mean he'd have 21 electrons here. 23 minus 21, how many electrons did he lose? He lost 2 electrons. Tin went from a plus 4 to a plus 2. Tin is gone for, I have to look at what he is, 50. Here he would have 46 electrons, and here he'd have 48. So what happened to his electrons? He gained. He gained 2 electrons. Okay? So, being oxidized in this case is chromium, and being reduced is tin. Next one, mercury is going from a plus 2 to a 0 because he's by himself. Did his charge go up or down? His charge went down, so he was reduced. Iron is going from a 0 to a plus 3, so iron was oxidized. Okay? What species is it that's being oxidized here? The iron is being oxidized. Here, the chromium was oxidized. All right, next one. Arsenic's by himself, so he's a 0. Now he's in a combination. If we do the math, chlorine's always a negative 1, so that's a total of negative 3, so arsenic must be a plus 3. Here, chlorine is a 0. So what's happened? Arsenic's gone from a 0 to plus 3, so arsenic has been oxidized. Chlorine's gone from a 0 to a minus 1, so he's been reduced. Now let's write half reactions for these guys. where's my square? There it is. I want white. Alright. Half reactions. We're going to take what's being oxidized and what's being reduced. We already said chromium was oxidized. So on the left side he's Cr plus 1. On the right side he's Cr plus 3. And he's losing 2 electrons. Tin is being reduced. Tin on the left side has a plus 4. On the right side he has a plus 2. So he gained 2 electrons. Now if I put those together, if I want to balance that, and I put those together, will my electrons cancel each other out? The answer here is yes. 2 electrons minus 2 electrons will be 0, correct? So we can put these together. We can take our chromium plus 1 plus our strontium plus 4. So we've pulled both of those into the equation. Now we're going to mush these guys in. And there you go. That, okay, I don't know what that was. I don't know how I got that there. All right. Probably Jeff again. Okay. Here, what's being oxidized? What did we say? We said iron was. Iron is going from Fe to Fe3+. So he's lost 3 electrons. Mercury, and we're not going to worry, even though the second mercury is diatomic, we're not going to worry about that. We just are going to recognize he's going from a 2+ to a 0. So he gained 2 electrons. So this iron's going to give off 3. Mercury's going to eat up 2 of those. That means they got to bring another friend to the party. We're kind of like when we're balancing or writing out compounds. If we have 2 here and 3 here, iron's going to have to happen 2 times in order for all the electrons to get used up. 3 times 2 is 6. Mercury is going to have to happen 3 times in order for all of our electrons to get mixed up. So I'm going to leave those electrons there for the moment. I'm going to bring these down. 3 mercuries plus 2 irons. I'm going to put the electrons in red. Oh, nope. We're doing blue for iron. 2 blue. And we're doing green for mercury plus 3 Hg and red. So if that's a math problem, you want to simplify, they cancel. What are you left with? 3 mercuries plus 2 irons. You're just bringing this guy down here, this guy down here. All right, one more. And then we're going to have to stop, and I will do part 2 when I get home. Wouldn't it be really funny if Jeff showed up right now and did something and freaked me out when I'm all by myself in the school at 7 o'clock at night? Arsenic here we said was a plus 3. Arsenic's going from a 0 to a plus 3. That means he's losing 3 electrons. Chlorine is going from a 0 to a -1. So he is gaining 1 electron. I want those electrons to cancel each other out. So I need 3 of these guys. I need 3 chlorines. Oh, I didn't do a different color. Sorry. 3 chlorines, and 1 times 3, I'm going to use red for my electrons. 1 times 3 is 3 electrons. Okay, now my electrons are the same, right? So arsenic, I'm going to bring him down. I'm going to put my blue chlorines in. I'm going to have 3 chlorines and 1 arsenic. Alright, this has been plenty long enough, I know. We will do the next part of this, which is asking about what's being oxidized and what's being reduced, which is part of the problem on the test. I'll take the stuff home and do it tonight at home after I get my hair cut. So you guys get to enjoy a new haircut when I get home. See ya.